Early Friday morning, SpaceX's first version 3 Super Heavy, Booster 18, rolled to Massey's for routine pressure testing. Engineers began adding pressure to the gas systems. Then a massive chunk of the lower oxygen tank peeled wide open. Could this catastrophic failure actually be exactly what SpaceX needed? Here's why this is good news. They found a critical weak point during safe gas testing before loading any explosive propellant. No fire, no site damage, just pure data. Welcome to Space Update 24 Hours. Let's dive right in. Booster 18 wasn't just any test article. This was the future. The first version 3 Super Heavy, redesigned from the ground up with separated quick disconnects for methane and oxygen, offset by 72 degrees to fit perfectly between the booster's strakes. SpaceX had just posted images celebrating its rollout, stating they'd test the booster's redesigned propellant systems and its structural strength. The team at Massey's began in the early hours of Friday. Standard procedure: pressurize the gas systems first, check for leaks, verify structural integrity before ever introducing volatile propellants. Then came the failure. A massive section of the lower liquid oxygen tank simply peeled open, exposing the internal transfer tube setup, which somehow became the only thing holding the weight of everything above it. Starship Gazer arrived first on scene. The footage was brutal, metal torn like paper, a vehicle that took months to build, reduced to a twisted shell in seconds. But here's what most people missed while focusing on the destruction. SpaceX designs these tests to fail. That sounds counterintuitive, but think about it. Would you rather discover a structural weakness during a controlled gas pressure test or during a full propellant load with 3,400 tons of liquid methane and oxygen on board? The difference between those two scenarios is the difference between valuable data and a crater. The test site suffered zero damage. No fire, no explosions, no injuries. Just one vehicle that revealed exactly where the engineering needed improvement before it ever threatened anything else. This is precisely what iterative development looks like when it works correctly. And SpaceX's response? They didn't even pause. The next version 3 Super Heavy is already in production. Ship 39, the first V3 upper stage, continued its integration in Megabay 2. The infrastructure upgrades never slowed down. Because this wasn't a setback, it was confirmation that their testing philosophy works. The same week B-18 failed, the transformation of Starbase accelerated at a pace that would seem impossible anywhere else. At Pad 1, demolition reached a fever pitch. Those 6 massive launch mount legs that had supported every Starship launch to date? Gone. One by one, excavators simply pushed them over in spectacular fashion. The 4th leg came down in what can only be described as controlled chaos. SpaceX literally throwing heavy machinery at the problem and making it work. By Friday morning, all 6 legs lay toppled, leaving the launch mount standing as a bare skeleton. The old booster quick disconnect hood, the drawworks hoist support structure, the commodities bunker at the tank farm, all stripped away in a single week. Why this frantic pace? Because Pad 1 is getting the full version 3 treatment. The new flame trench design that proved itself at Pad 2 is coming here. The reversed hoist system that provides better support. The robust angled structure visible on Tower 2. SpaceX is essentially rebuilding their first launch site from the ground up while maintaining an active flight schedule. Over at Pad 2, the new infrastructure started looking complete. Both quick disconnect hoods, liquid oxygen and liquid methane, were finally installed on the orbital launch mount. These are the separate systems the V3 boosters need, each perfectly aligned to mate with their respective connections. Well, almost perfectly aligned. By Thursday night, crews had already lifted the LOX hood back off for adjustments. This is the kind of precision work that separates a test stand from an operational launch system. Every millimeter matters when you're connecting systems carrying cryogenic propellants at hundreds of gallons per second. Then came Tuesday's big moment, the ship quick disconnect arm, that incredibly complex piece of hardware with 3 swivel joints and intricate pipework, finally rolled to the launch site. The scale of this thing only becomes apparent when you see the crew standing beside it. Without Starship there for reference, you realize just how massive every component of the system truly is. And the end piece? The business end that actually connects to the ship. That showed up at the Sanchez area, ready for final outfitting before installation onto the arm. The actuator that moves it all was already mounted on the manifold. Piece by piece, the puzzle was coming together. Inside the Star Factory, the future kept taking shape. Ship 39's final aft section, the piece that holds the Raptor engines, rolled out and headed to Megabay 2. The bridge crane lifted the existing stack, aligned it with the new section, and performed the double lift over to the welding turntable. This marked a milestone, the first fully stacked version 3 ship. Transfer tubes would be integrated next, followed by mission-critical systems. If cryogenic testing in December goes smoothly, Raptor 3 engines and flaps get installed, then it's off to Massey's for the first upper stage static fire since Ship 36's fiery end back in June. 5 months. Think about how much has changed in just 5 months. Meanwhile, Booster 17, a previous generation vehicle kept as backup, met its end. The carbon dioxide tanks came out from under the strakes. The vehicle rolled into Mega Bay one final time. Then crews simply cut it in half above the common dome. The LOX tank went outside. The methane tank got sliced into 4 manageable sections, lifted out piece by piece, with the forward dome coming last. One generation retired as the next prepared to prove itself. This is the cycle of progress. Despite B-18's failure, the Massey's test site showed it was ready for what comes next. Sean's boat tour around the facility revealed the ship quick disconnect on its support structure, with propellant lines running almost to the top where a plate system awaited flexible connections. The clamps for the next generation ship sat installed on the static fire stand. The massive concrete flame trench cover had moved back across the opening. The blast wall protecting the methane tank farm was poured on the left side, with formwork continuing on the right. Everything pointed to one conclusion. When Ship 39 arrives with engines installed, this site will be ready to light them up. While SpaceX dealt with its B-18 setback, Blue Origin was riding high. The New Glenn first stage, Never Tell Me the Odds, arrived back at port looking pristine. That methane-fueled BE-4 engine burns incredibly clean compared to Falcon 9's kerosene. No soot, just carbon dioxide and water vapor. Maintenance requirements will be dramatically lower. The week brought even bigger news. Blue Origin dropped specs for New Glenn 9x4. 9 BE-4 engines on the booster. 4 BE-3U engines on the upper stage. A total of 5.7 million pounds of thrust at liftoff. 70 metric tons to orbit in a single launch. A full-scale deployable aerobrake for atmospheric deceleration, potentially even for point-to-point transport. This is the future Blue Origin sees. And after landing that first stage on only their second attempt, people are starting to believe they can deliver it. Falcon 9 kept its steady rhythm. 3 launches in 1 week. Sentinel 6B from Vandenberg marked the 500th reflight of a Falcon first stage. 2 Starlink missions added another 58 satellites to the constellation. Rocket Lab launched twice in 48 hours, hitting 18 missions for the year. At the Cape, construction surged forward. The Gigabay's second level rose at Roberts Road. The 4th Starship Tower's 8th segment took shape. Components for the 9th and final segment had already arrived. A full tower, ready to be assembled and shipped. The launch mount at SLC-37 sat installed in its flame trench, with leg reinforcements already in place before it even arrived. SpaceX's VP of Launch shared footage from below, looking up through the flame bucket as the massive LR-13,000 crane positioned it perfectly. All of this, the demolition, the construction, the testing, the failures, the successes, happening simultaneously. This is what building the future actually looks like. Messy, chaotic, unpredictable, and absolutely relentless. So let's address what actually happened this week. Yes, Booster 18 was destroyed, but SpaceX gained something far more valuable. Proof that their testing protocols work exactly as designed. They found a critical flaw in a controlled environment with zero risk to people or infrastructure. That's not failure. That's engineering done right. While 1 booster fell, an entire launch site evolved. 6 launch mount legs demolished. New quick disconnect systems installed. The ship QD arm rolled out. Production continued on Ship 39 and the next V3 booster. Blue Origin pushed boundaries with new Glenn 9x4 specs. Rocket Lab hit 18 launches for the year. This is the reality of building the future. Every setback carries a lesson. Every destroyed vehicle reveals data that makes the next one better. SpaceX didn't slow down after B-18's failure because they understand something crucial. Progress isn't about avoiding mistakes. It's about learning from them faster than anyone else. The next version 3, Super Heavy, is already coming, and when it stands at Massey's test site, it'll be stronger because B-18 showed them exactly where to improve. That's your space update. If this breakdown gave you a new perspective on why failures can be victories, hit that like button. Drop a comment with your thoughts on V3's future, and subscribe to Space Update 24 hours so you never miss what happens next at Starbase. We'll see you in the next one.